Alright, so we're going to continue talking about radicals and rational exponents here. So on top of adding and subtracting and multiplying, we're going to go into talking about dividing these guys, alright? So dividing radicals. So if a radical expression contains a radical in its denominator, it is agreed that it is not in the simplest form. So if it's in the denominator, it's not in the simplest form. So example here, 1 over the square root of 2 is not simplified. But an equivalent form is the square root of 2 over 2 that is simplified. So to eliminate a radical form, its denominator, we can we use a process called rationalizing the denominator. Okay, so we will be looking at two types of rationalization problems. Rationalize the denominator containing one term and then one containing two terms. We will use the idea that multiplying a numerator and denominator by a fraction by the same quantity, let me repeat that. Multiplying a numerator and denominator of a fraction by the same quantity results in an equivalent fraction. So with this, well, we've got one square root. So the goal of rationalizing is to eliminate the radical from the denominator. So recall, so we take the square root of 2 times the square root of 2. Again, that gives us square root of 2 squared. That equals 2. Okay, guys, 1 second. So again, with that, that's the same thing as taking, remember, if we take alright, so again, that's like if we have 2 squared, but then that square root is like saying times 1/2, okay? Another way we could, let's go and write that out. So that could be 2 equals 2 to the power of 2 over 2, which is equal to 2 to the power of 1, right? However, you can also look at this rule as well, okay? Because you can also do this pretty simply. Let's say we have our number x in there, okay? And we have our b root and our a power. That's the same thing as saying x to the a over b. That looks horrible. Let me write that x a little bit bigger down here. Oh my goodness. All right, so x to the power of a over b. So same thing here with 19. We can do the same thing. Same thing with our m's. We're just taking square root of m squared. It's just going to give us m. So we'll use this property to rationalize denominators. So again, we got 2 over the square root of 5. So to do this, we want to eliminate that square root on the denominator. So we're going to multiply by 1. Because if you take a look at this, again, remember, anything over itself, so if we have square root of 5 over square root of 5, that is the same thing as 1. Well, if you multiply anything by 1, it doesn't change. I mean, the numbers will change, of course, but the actual overall value will not change. So to get that radical off of the denominator, we're going to do that. So we take 2 over square root of 5, and we're going to multiply it by 1, or in this case, square root of 5 over square root of 5. So when we do that, that gives us our little trick we had that we just did above there, where we had square root of 5 times square root of 5 gives us square root of 5 squared. And up top, we're just left with 2 times square root of 5. Okay, so again, if you do that, you can simply write it out like this, or if you understand that square root of 5 squared is the same thing as saying 5 to the power of 2 over 2, you should understand it's just 5, right? It's 5 to the power of 1. In which case, that's what they did. So you just have up top, you can't simplify 2 times square root of 5 any further, and then you're simplifying that radical on the denominator and taking the square root of 25, which equals 5. So And note, in the simplest form, right, we cannot reduce items inside and outside of the radical. So you cannot simplify that any further. Notice what they're saying is you cannot simply take this and cancel these guys out. That's a no-go. No, cannot do that. Incorrect. All right. So therefore, cannot do that. So on our second example here, so we're going to do this again. So we've got 4 with the square root of 20. So again, to get rid of that square root of 20, let's take care of it. So let's go ahead and do that. And this time, what we did here, we also just went ahead and broke down that square root of 20 here, okay? Because we want to simplify it before we have to multiply it, these big numbers. No reason to make that big square root of 20. So let's go ahead and we can simply say square root of 4 times 5. And if we use the multiplication rule there, again, that's like saying square root of 4 times square root of 5. And you should realize that this is 2 times 2, right? So we should be able to take a 2 out of there. We should be able to take a 2 out of there by taking the square root of 4. Okay, which we did. We took square root of 4 is 2. Square root of 5, of course, is square root of 5. And we still have the 4 on top. So now, let's see what we got here. We got, simplify this by taking 4 divided by 2, in which case 2 goes away, goes into 4 2 times. Now we got to get rid of the square root of 5 on the bottom. So see, we didn't have to worry about the square root of 20. Now we're going to take care of the square root of 5 on the bottom. So again, multiply by square root of 5 or square root of 5. And we're going forward with a very similar problem we just had, right? So again, this is like saying 5, 2 over 2. So therefore, that is equal to just 5. It's 5 to the 1 power of 1. Okay? And therefore, that's what we get. And overall, that is going to be our answer. Sorry, I clicked a little fast there. This is our answer, again, just like the previous problem. However, we just had to simplify the square root of 20 before moving forward. All right, another example here. Rationalize the denominator of each expression. So with this one, square root of 6 divided by 20. So let's simplify the fraction under the radical. So if we've got this, we can go ahead and take this and simplify that fraction, because 2 can definitely go into both of those, right? 6 divided by 2 is 3, and 20 divided by 2 is 10. So now we have square root of 3 over square root of 10, because it's the same thing as saying square root of 3 over 10. We're just using the division rule here of the radicals, okay? So now let's rationalize the denominator. So we can simply take square root of 10 over square root of 10, multiply that by square root of 3 over square root of 10. So this is like multiplying times the number 1, okay? It's the same thing. It's like just multiplying times the number 1. All right, so therefore, if we take square root of 3 and square root of 10, that gives square root of 30. The square root of 10 and square root of 10 gives us square root of 10 squared, which, again, you should realize is that what's that going to give you? 10. All right, so to give you that answer right there, that's just going to be the answer. It's like saying 10 times 10. All right, in which case, that's all we get. Square root of 30 on top, nothing else can be simplified in there, and we just have a 10 on the bottom. All right, simplifying completely with these. So on A, we got 7 over square root of m. Well, just because of a variable in there doesn't mean it's going to change anything. It's just like a number, but we need to get that radical off of the denominator. So to do that, we're going to rationalize the denominator. So what we're going to do, multiply by 1, right? We're going to multiply by square root of m over square root of m. So that is like multiplying times the value of 1. Anything over itself is 1. Now, that's going to give us on top, we should get 7 times square root of m, and on the bottom, square root of m squared. And again, you should realize that this gives us down here, square root of m squared should be given m. This ain't m to the 2 over 2, which is just equal to an m. Now, can you rationalize any further? Can you simplify any further? No, right? Because this is all we've got. This is all we've got. Sorry, I clicked the button there. The next one here, for b, we got square root of 27 times p to the 4th power divided by q to the 3rd power. So, what do we need to do here? Can we simplify that any further inside? No, it doesn't look like it, right? So we're just going to go ahead and actually just break this down into setting this up, our division of the radicals. So on top of square root of 27 times p to the 4th divided by square root of q cubed. So with that, now let's see if we can break that down a little bit further. Because at 27, we can knock that down to 9 times 3. And then to get an even, well, let's see what we do on the denominator. We should take the q squared times q. We should break that up to where we can actually maybe pull out just a variable itself. That's what we're going to do. So again, we're taking 9 times 3. And hopefully you will see here as well, 9, of course, if you take the square root of that, 3 times 3. So we should be able to take out a 3 on that. Okay. So we'll be able to take a 3 out of that. And then on the bottom denominator, if you have square root of q squared, that should just equal q. So they're going to go ahead and break it out and make it a little bit more apparent. And on top there, I even overlooked it. We got a square root of p to the 4th. So what should we get out of that? Well, hopefully we'll get a p squared. If you look at that, again, using our rule, if you were to write this by using that trick I showed you in the beginning, that's the same thing as saying p to, what do we got here? 4 over 2, right? So therefore, we should get p squared. And we did. We were able to pull out a 3 that we showed down here. So we got this guy is here. We got that guy right there, a 3. We got our p squared right there. And we're going to leave the square root of 3 because I can't be simplified any further. Then we pulled out our q that we talked about. That's right there. And left with the square root of q. I don't write that in front. It looks like I'm saying the square root of q again. It's check mark. All right. So again, then let's write this without the multiplication symbol in there, make it look a little prettier. And that is as simplified as we should be able to go. Oh, let me erase some of this. Oh, what am I talking about? Rationalize. Look at that. I'm moving too fast. We got a radical on the denominator, so let's fix that. I overlooked that completely. So let's get that out of the bottom. So again, let's multiply it times square root of q over the square root of q. Again, that's like multiply times 1. In which case, again, we still have 3p squared on top times the square root of 3q, because that q just goes inside the square root there. And on the bottom, we've got q times the square root of q squared. So we know this should come out and just give us a q. So on the bottom, we're going to have q times q, which is q squared. So up top stayed the same, numerator is the same, denominator is q squared. Now, that is our final answer. I apologize for going too fast. I'm trying to jump through these pretty quick. Totally overlooked that radical on the denominator. All right. So example 5, simplify completely. So looks like we got the problem right here. Square root of 10xy divided by x to the fourth times y to the squared. So we're going to simplify the radicand using the quotient rule for exponents. So with this, again, you can just simplify it because you have x on the numerator and denominator and y on the numerator and denominator. As you can see, these are both 1s, x to the power of 1 and y to the power of 1. Well, this, you can just subtract this. So therefore, we got 4 minus 1 give us x to the third. And y squared minus 1 gives us just a y. So therefore, we're left with this value, square root of 10 divided by x cubed times y. All right, so now we can break that down. Square root of 10 over square root of x cubed times y. Now what do we do with that x cubed? Let's go ahead and break that up and simply say that we may have, well, let's go ahead and split by the product rule first. Say square root of x cubed times square root of y. Let's go and break that up. Now we can simplify those x's. We can take square root of x squared times x times y on the denominator, times square root of y, on the denominator. Because now this should allow us to take an x out of there. In which case it does, right? So we got square root of 10 over x times the square root of x times square root of y. Now we can't really do anything else simplify square root of x times square root of y, so let's just go ahead and write that as far as square root of 10 divided by x times the square root of x times y. Now what do we need to do here? We still have a radical on the denominator, something I overlooked the last example. So we're going to fix that though, right? Now we rationalize the denominator. So since we took this initial problem right here, and brought it to this guy right here, now we just need to get this off of the denominator. We need to get that square root of x times y. So let's rationalize it. So multiply it times 1, which is square root of x times y over square root of x times y. We multiply those together. You get square root of 10xy divided by x times the square root of x squared y squared. Now we can simplify this. It makes it a little bit easier, right? Because if you look at that again, it's square root of x squared, square root of y squared. That's how we got just an x and a y. We've been looking at that every example. So hopefully you're kind of catching on there, and that's making a little bit more sense. And that's why we got over here when we simplified it x times y. So that's our x squared that we took the square root of. That's our y squared we took the square root of. So now what do we need to do? Well, let's just go ahead and multiply those x's together and write it out completely. So now we've got square root of 10xy over x squared y. And we have no radical on the denominator. Oh, there's the problem. The clicks are out of order. My bad. So again, so we're going to the next one, but that was our answer overall. I'll go ahead and box it up for us. All right, so rationalize the denominator, one higher roots. Many students assume to rationalize denominators, we simply multiply the denominator and numerator of the expression by the denominator as in the previous section. So to rationalize an expression like 5 over cubed root of 2, we must ask ourselves, by what do I multiply cube root of 2 to get a perfect cube under the cube root? The perfect cube we want is 2 cubed. Since we began with 2, so that the cube root of 2 times the cube root of 2 squared would equal the cube root of 2 cubed, which gives us 2. In other words, they're making it look just like we talked about. Instead of having a square root, we're using a cube root here. So in other words, you want this to be just like what we've been talking about, right? When I said that we have the simple fact of 3 and 2, 3. So that is the same thing as saying 2 to the power of 3 over 3, which is saying 2 to the power of 1, which equals 2. So that's all they're wanting to say. So in other words, to get that cubed root of 2, to get rid of that cube root, we have to multiply it times cube root of 2 cubed, cube root of 2 squared to make cube root of 2 cubed. So a lot of cubes. I'm speaking really fast. Hopefully that makes sense. Again, this is what you have to multiply it by to make this to give you the overall 2. All right, so let's practice. So to fill in the blank with here, now again, we've got, let's look at this, and we have 5 to the 1 power. So if I want to multiply this times what to get 5 cubed in there? Well, hopefully you can see that we just want to multiply times cube root of 5 squared. We just need a 5 squared in there, okay? And then we make the rule work just like we did above. Okay, so fill in the blank on these again. With this setup here, we've got the same thing here. Again, with 8 though, we can play around with 8 a little bit, right? Because 2 cubed is also 8. So if we were to write 2 cubed here, what we need to make 2 to the 5th power? Well, we need a 2 squared, right? And that's what they're going to show you. As far as if you break down the 8, since this one is to be in the factors of 2. Now for B, we have x in here. Again, if we have x squared, what do I need to multiply by to get x cubed? Again, disregard the radical for the time being here. We know we need to equal a 3. So we took x squared times x to the first power, right? That gives you x cubed because you add your exponents. Then you can look at it and say, oh, well, then there's also that cube root. So if I took the cube root of x cubed, yes, that would give me x. So that is what you're doing to find the missing value in there, okay? In which case they walk us through that process right there that I just talked about. And now let's do an example, okay? So let's rationalize the denominator. So first identify what we want the denominator to be after multiplying. Well, we want to obtain a cube root of 3 cubed. And therefore, since the cubed root of 3 cubed would equal 3. So how do we get that? So we've got 8 over 3, or cube root of 3. So let's make, if this is just a 1, and we want this to equal just 3, if we multiply 3 to the first power times 3 squared, that should give us 3 cubed. And then we would take the cube root of 3 cubed, which would give us 3, okay? So it's exactly what we're going to do here. That's why we multiplied times cube root of 3 squared. So now, what does it give us after we multiply that? So again, we have 8 times the cube root of 3 squared divided by the cube root of 3 cubed. And what happens to that? We need to simplify this. So what happens to this guy? Well, that just turns into 3. Okay? And since we can go and multiply this out, it's not going to simplify any further. We know that 3 squared is simply 9. That's where they got 9 from. And that's as far as we need to go on that one. So that is your answer to eliminate that cube root on the denominator. All right, so to rewrite this guy, we've got the fourth root of 2 divided by 9. So we can break that down as far as saying the fourth root of 2 divided by the fourth root of 9. So then we need to write 9 as 3 squared. So let's go ahead and do that so we can see what we need to get rid of here. So to get rid of that, we need to have a 4. This 2 right here needs to become a 4, right? So that it'll turn into a 3. Okay, so since we want that to turn into a 3, what do we need to multiply? Well, since we need this exponent of 2 to turn into a 4, what do we need to multiply this by to get a 4? To rationalize the denominator, we want to multiply it exactly by itself, right? Because 3 squared times 3 squared is going to give us 3 to the 4th, which is what we want. So when we take the 4th root of that, it just gives us 3. So we're going to go through that process there. Again, we're multiplying the numerator times the cube root of 3 squared as well. We multiply that together, in which case we can just combine those on the top there in the numerator for 2 times 3 squared. On the bottom, though, we should be able to simplify that to get a 3, right? And since we took 9, this was 9 times 2, that gives us 18. And there we go. That's as simplified as we can get it right there. All right, let's rationalize the denominator by that contains 2 terms. So with this, we have, instead of just a square root of 3, just a radical down there, what do we have? 5 plus square root of 3. So we have 2 down there, okay? So with this, we multiply the numerator and the denominator of the expression by the conjugate of, in this case, 5 plus square root of 3. So the definition here, conjugate of a binomial is a binomial obtained by changing the sign between the 2 terms. So instead of a plus sign in this case, we're going to put a minus sign. And that will make things a lot easier to work with. So in this case, if you were to look at the expression square root of 7 minus 2 times square root of 5, the conjugate would be the same thing, but with a plus in the middle. If you have square root of a plus square root of b, well, the conjugate is square root of a minus the square root of b. So again, we talked about this in yesterday's lesson. Recall that a plus b times a minus b is equal to a squared minus b squared. So in this case, it'll work out the same way that we're talking about. We can do this quick little trick with this, okay? So with this, let's multiply 4 plus square root of 3 by its conjugate. See how it plays out. So if we do this, do the FOIL method, right? You take this, the conjugate of that is 4 minus square root of 3. And of course, do the FOIL method, first outer, inner, last. You can do it that way. And it should give you, again, 16. And then minus our square root of 3 times square root of 3, because since we have a negative there, and we have a positive there, since we have a negative here, positive here, these guys go away, and that's where we're left with that, which gives us 16 minus square root of 9. Square root of 9 is simply 3. 16 minus 3 is 13. So if we do this method will give us the same results, because we can look at this by saying our a is 4 and our b is square root of 3. Well, if we do that, we square 4 and we square the square root of 3 simply by saying if we have 16 minus 3 like we just did, and this right here gives us 13, okay? So we'll do one example like this where it's on the denominator. We need to get rid of this. So we have 3 over 6 plus square root of 2. Well, let's multiply by the conjugate. So we're going to multiply the numerator and the denominator, okay? Because again, you got to multiply by 1. So where you're not changing the problem altogether. So if we're going to multiply the conjugate, you're going to take 6 minus square root of 2 times numerator and denominator, okay? So if we do that, get it set up just like this, but we can use that little trick, right? Use that FOIL or a little trick there to work on that. And let's use this one right here because that makes things a lot easier, shall we say. So on top we have 3 times 6 minus square root of 2. On the bottom we have 6 squared, which was 6 was our A, and B is our square root of 2, so the square root of 2 is squared. So we're going to simplify this, in which case on top, if you distribute that 3 times everything in the parentheses, you get 3 times 6, which is 18, minus 3 times the square root of 2. And on the bottom denominator, we have 6 squared, which is 36, minus the square root of 2 squared, which is simply 2. So that should give us 18 minus 3 square root of 2 divided by 34. And we don't have to do anything else to simplify it because, well, there's no radical, goodness, I'm getting tongue-tied, no radical on the denominator. So therefore, we're good to go. All right, so that explains everything for dealing with division of radicals. Hope you learned a little bit of something today, and I'll see you next time.